Yes, so let us start with this session. In our previous sessions, we have discussed it with the design implementation of our decoder-based RAM. Let me share my screen so that you can see this, what we have discussed so far. Yeah, please confirm me whether my screen is also visible so that we can start this discussion. Okay. So we have started with our. So previously we have started with what is our like how you are going to develop a system and locations, like what you're going to have the verification plan. Next, what is the structure you're going to have for this particular verification purpose, and what is the design you're going to have. Give me 1 second. Yeah. So we have started our discussion about this particular design, like how we are going to have this, and what are the input ports and output ports we are going to have, and what do you mean by test and what do you mean by interface and top we have seen, and we have also discussed about what do you mean by transaction and all. What are the steps for creating your test bench architecture we have seen, right? And yeah, and also we have seen how we are going to send a transaction object to my DUT, and yeah, and also we have started with our design, our decoder based RAM design we have started, and we have seen the architecture, and we have successfully implemented using the Verilog. Okay, and yeah, this is what we have seen so far, and in this session we will start with 1 minute. Someone has unmuted their mic. Okay. So in this particular session, let's start with our interface. Okay. So we are going to discuss about how we are going to develop an interface and what do you mean by interface. We have discussed it previously, but let us see how we are going to develop an interface file. So this interface file is going to have, give me 1 second. So you can refer the playlist. We have discussed it in detail, like what we have discussed it. So, like briefly, if I wanted to wrap it up, like we have discussed about just the design, like we have designed a 2x4 decoder based RAM design, where we are going to have four memory blocks for controlling them. We are going to have a decoder like design, and we are going to design it. And using the first two bits, we are going to decide which chip we want to communicate with, and remaining bits use it to access the location of each particular chip. Okay, you can refer to the playlist already. The recordings have been uploaded. Once you can refer them. Okay, yeah. So in this particular session, let's build a interface. So this interface block is going to have all the signals which we want to shade it with my design as well as test bench. So let me create a file over here, and I hope my screen is not visible, right? Yeah. Yeah, I will share the link. 1 minute. Are you there in the group, WhatsApp group? Are you there in the WhatsApp group? So this decoder based RAM design, only two sessions we have done, right? So this is the third session. So I'm going to declare an interface, and this interface, let's give it as RAM underscore interface. And this is going to have the input as clock. Okay. Now, what are the signals I need? So I can refer to the signals which are present over here. So this particular RAM design clock is going to be given from the top, and reset we are going to have write enable, read enable. So I'm going to declare them. So logic reset underscore n. Next logic write enable, and logic read enable, and I also have something known as address. So write address and read address. So for my design, I have, where is this? Yeah, write enable, read enable, and address. So logic address, and I have W data. W data is nothing but write data. Logic W data, which is of how many bits width? It is of 8 bits width. Okay. And address is also address is 7 bits width. So it is 7 down to 0, and this is 6 down to 0. Address, next data, W data, and R data. Logic 7 down to 0. R data I'm going to have, and this is 7 down to 0, W data, right? And next I have, apart from this R data and W data, have something known as valid. So about what do you mean by valid and all, we have discussed it previously only. So I'm just declaring this particular signals, right? And followed by end interface. So these are the signals which I'm going to declare it in my interface so that I can reuse them inside my test as well as in my design. Okay, when I'm instantiating, I'm going to use them. Now, can anyone tell me why I'm going to use the data type as logic? Why can't I use reg, or why can't I use wire over here? Why I'm using logic for this particular signals? Why can't I use simple reg or wire? Any idea, anyone? Basically, this logic, if you are going to declare any particular signal as logic, then it can be used in your procedural assignment blocks as well as continuous assignment blocks. Okay, that's the reason I'm going to declare all these particular signals as logic. Okay, next, let me declare the file which is my transaction. So this file, I'm going to basically have all the particular inputs. That means my write enable, read enable, address, and W data to be declared as rand. So I'm going to declare them with rand keyword so that this particular variables can be randomized. Okay. And apart from this, R data, valid, and D out signals are not declared as rand because I'm not randomizing them. My design is going to give them, and I'm going to store it in my transaction file. So what I am doing now over here is, next is my transaction file. So if I'm going to declare this transaction file, in this transaction file, I'm going to declare my input variables with logic, and output variables I'm not going to declare with them logic. Okay. So this transaction file is going to have what are all the input signals which should be randomized, and also the output signals. Just I'm going to have it so that I can reuse it in my monitor and scoreboard. I will show you how I'm going to use this transaction file. Now, this transaction file instance is created in my generator. So generator is going to create the transaction file object, not only generator, like I'm going to have my monitor going to create it, and how it is going to use, I will show you. Okay. So this generator is creating the transaction object, and after creating the transaction object, this object is sent to my driver via the mailbox. So via the mailbox, my generator is going to send this particular transaction object to my driver. Okay. So this process we are going to see it now. Let me create my transaction file over here. So just I'm going to write it down, class transaction, and next I'm going to declare one variable of enum data type. So using type def, let me create it, enum. So this particular variable is going to have write and read. Okay. And let's say the variable name is op underscore. That means operation. So which type of operation should we have? Whether we should have write operation or whether we should have read operation. So only this op underscore t will have only two options, either to have a write or either to have a read. And this is a data type. We are going to create a variable now. So rand uh, op underscore t is my data type, and the variable here is op. Okay. And also rand 6 down to 0 address, and 7 down to 0, W data, and so this should be of, let's declare them as logic. What happened to this? 6 down to 0, logic. And this is of also logic data type, 7 down to 0, R data we are going to have. And apart from this W data, R data, we are going to have logic valid, which is an output to my design. This I'm going to have it as simply valid. Okay. Yeah. So these are the variables which I'm going to randomize: OP, W data, R data, valid, which I'm going to have. Now, so after this, I'm going to have a new function where I'm going to just initialize them. Function new operation. By default, I'm going to have it as write, and address, I'm going to give the default value as 0, and W data, I'm going to give the default value as 0, h00, and R data also I'm going to give the default value as 0, and yeah, and valid is also equal to 0, one tick binary 0, and followed by end function. Now, whoever or whichever module is going to call this transaction instance, or whoever is going to create the transaction instance, uh, whenever they are going to call the new function of, whenever they are going to call the new function, all the variables will have their default values. For example, if in my generator, I'm going to use this transaction object, and if I'm going to write down tr is equal to new, then automatically this new function will be called and all the instances will be created. The transaction object instance will be created and all the variables will have their default values. Okay, that's the reason I'm going to have it in my new function. Is it clear, guys? Any doubts or any queries up to here? Shall we move forward? Is it clear? No, no. We are reading, right? Our data should not be randomized. Our data will be given by your design. Testbench is giving W data. Our data will be given by your design. Read data. Okay. Now, apart from this, let's have a particular function for printing the information. So in my transaction class only, I'm going to have one function which is of return data type void, and this function is going to print. So let's have a particular argument which is known as tag, and this particular argument, whoever they are calling this particular function, let's say suppose write driver is calling the function print, we are going to have the argument as write driver. So whoever is going to call that function, they need to pass the argument. Okay, and let's display $display. So at which time we are going to call this function percentage zero t, so to avoid any gap, and let's have operation value. What is the operation value we are going to have? What is the address value we are going to have? So which is percentage. Let me let me show it in my hexadecimal format, and data percentage h, and apart from that our data which is percentage h. Okay, so all these particular variables I'm going to display them. Okay, and yeah, and also valid is equal to percentage b. So valid is only either 1 or 0, and yeah, and for displaying the time I'm going to use $time, and for operation I'm going to use simple op, and address is addr, and w data, and R data, and valid. Okay, so these are the things which I'm going to have. Okay, and for we close this. So this is my function print. This function, if I'm going to call from write driver, read driver, write monitor, or read monitor anywhere, I can call this particular function which is present in my transit. Hard data, I have mentioned it as random. Okay, sorry. Simple logic hard data. Is it fine? Yeah. So this is my transaction file. Now, if I want to call this print function, I need to use this transaction class handle and I need to call the print function. Then only I can able to call my print function. Okay. Now, your small task is you all can try building a generator class, and in this generator class, declare a transaction class handle, create the transaction class object, and randomize the data, tr.randomize it. Okay. And after that, after randomizing it, try to send the data from this generator. I mean, try to send this particular randomized transaction object to my driver. This is a small task using the mailbox. Okay. If you can try, give it a try, or else, anyways, I'm going to explain in this tomorrow session. So, first of all, try to complete this interface and transaction. You can do the coding parallelly so that you will have like better understanding what is happening. Okay. Yes. So, that's about this particular session. And give me 1 second.